It's time to get our hosting on. By the time we're done here, we will configure static NAT mappings for a hosting environment. So static NAT is exactly that. When you think of dynamic NAT, when you think of NAT overload, these are things that kind of work in a more dynamic system where as things come through, it builds NAT translation for X devices, however many are coming through, and passes them through, recording all of those things dynamically in a table. Well, static NAT is exactly like it sounds. It's where you and I get into the router and say, bam, I'm tacking up this NAT translation to where when this IP address comes, it will become this, and it will go out, et cetera, et cetera. We actually can do that. Now, there's two ways that we can do static NAT. The first is by doing it on a IP address basis. That is, I might have, and here's literally what I'm going to set. Oh, darn it. Hang on. I got to fix that. There we go. 50 was actually in use on the network. So the web server became 10.16.0.200. So let's just put this all back in perspective here. You remember VLAN 10? That was our static devices VLAN. That's where we have our servers, our management devices, et cetera, et cetera, et cetera. Let's just say that we have a web server, 10.16.0.2. And by golly, we do. It's called my Apple laptop right here. You can see that I have the Apple laptop following this Ethernet cable connected up here into that access switch. This is actually on port 2021. Is blinking right there. And I don't know if you can see it. It's kind of, it might be a little faded, but it says it works. This is actually the default homepage of Apache web server in OS X Mojave, right? Or Mac OS Mojave version. So that's the default page when you install an Apache web server on there. I know it works. As a matter of fact, let me come back here. What I've got is I've got my computer. I'm messed up here. This guy is actually Fast Ethernet 0/21. I've got my computer plugged in right here. Still from the last video, it was on port 23, and it is in VLAN 30. So it's got an IP address from there. Our web server's in VLAN 10. So it just, I don't know why I always feel the need to just make sure all the dots are connected. I want to go in and actually I still have my console cable connected to the switch right here. I just want to show you how everything is configured. So I'll bring PuTTY up. You can see I was just configuring a moment ago. I'm going to do a show VLAN. And you can see that I have interface Fast Ethernet 0/21. That's my web server. It's in the static VLAN. I've got my client computer right here in Fast Ethernet 0/23. Now, I want to show you what I'm going to do first to test is I'm going to go into my client computer. Hang on, let me get my sketches back up here. There we go. I'm going to go into my client computer, and I'm going to access this guy right here. Now, they are on different VLANs. This is not testing static NAT. It's going to test my router on a stickness. That it's going to come in here. It's going to say, okay, I'm going to my default gateway. I'm coming back out on VLAN 10, and I should be able to access that web server. There's Firefox. It was 10.16.0.200. It works. My whole purpose for doing that is actually for you and me, because I was like, oh, sure. I didn't know if I turned off the firewall and all that. So it does work. I can access it. Now, remember, this is from inside of the network. It just verifies my computer can go through that router and access it right here. It's not using NAT at all. What I'm going to do is I'm going to disconnect my computer from right here, and I'm going to move it out onto the internet. The way I set up VLANs here in my studio, I can actually have it on the outside of the network coming in, and that will allow us to test. So let's do some disconnection here. I'm going to go over here and actually yank this guy right here. It's gone. Okay, now all that's left is the web server, and I'm going to connect it, and I'm going to do it virtually, meaning I'm going to go into the interface that was connected to the inside of our network. I'm going to disable that. It's gone. And I'm going to enable the LAN adapter. So that is what is going to allow my computer to actually be connected out here on the internet. It's no longer on the inside of the network. It's from the outside coming in. Okay, so just to verify, make sure that we're all on the same sheet of music. I'm coming back here to Firefox. I'm going to hit the refresh button. And you can see it's just loading, trying to connect. We're not getting there. I'm also so here's what I'm going to do, and I'll build our scenario here. I'm going to create a static NAT mapping to where the IP address 203.0.113.3 is going to, so when somebody accesses that from the outside world, it's going to go right in here and pass to the web server. Again, static NAT is typically used for outside-in mappings, although when you create this map, it's going to be two-way, and I'll show you that when we get to the configuration. The good news is because we have NAT overload configured, one of the pieces is already there. So when we're doing static NAT, first off, we have to identify our interfaces. So if you haven't already identified which interfaces are on the inside and outside of your network, you need to do that. You remember that was where we went into the interfaces and typed in IP NAT outside under this one, and that tells it that's the outside, this is the inside, this is the inside. So that's already done. We did that in the previous video. The second thing we need to do is globally, it's a global command, build our static NAT mapping. That's where we'll go in and tack up. It's going to feel that way. We're going to tack up a translation from the outside, 203.0.113.3, to the inside, 10.16.0.200. Now, just to make sure, I don't know why I feel like I'm doing a magic trick. So hang on, nothing up my sleeves. I'm going to show you Firefox. I'm going to verify we cannot reach this IP address, 203.0.113.3. I'm saying that so I remember it. You can see our request timed out internally. I'm going to type in 203.0.113.3, hit the enter key, and again, we're loading. You can see, timed out. We're not connecting because that is not online. Okay, so first off, I want to make sure I have a given. I'm going to say given we have the ISP who has assigned us this IP address. So obviously we've got a /29 right here. So we quote unquote own 2 through 7 because they're using .1. So 2 through 7 as addresses that we can use. Now 3 is not yet assigned to the router, but that's what I'm going to do right now. I'm going to open up my console connection. Oh, I'm still over on the switch. So let's take our console cable, move it over here to our router. Click. Okay, we're on there. Back to PuTTY, hit the enter key, get logged in. Now, first and foremost, I'm going to verify I can do a show IP NAT translations. I can see that I still have the dynamic, the NAT overload configured. And you notice this now is my web server. So again, it's a Mac computer. It's doing all kinds of things. It's got chickens on it. I mean, behind the scenes, it's got all kinds of things that are happening which bring the internet access. And those are all translating through right here using the NAT overload configuration. So let me just do a quick show run include IP NAT. And you can see I've got that's all the interface identification. We're doing the pool of public addresses. We've got the command still in place. So this doesn't have to replace the command. It's going to supplement it. We go into global configuration mode. I'm going to do this global command, IP NAT. Now this is where it's going to get tricky, and you could stumble when you get here. You might think, okay, well I'm going to go outside in, right? This is the perspectives of NAT. What I do, and I would suggest you always do, is keep the perspective the same. When you define an inside-out translation, it works just as well for outside-in. It's just the perspective of the command. So if I were to type in IP NAT outside, then it's going to say, okay, what's the outside address? And I kind of flip the whole story from what I'm used to. And that, to me, makes it more error prone. I always stick with one direction. I'm going to say, I want a NAT from the inside of my network, right? And all that means is I'm just going to type in the inside address first. So let's do it. I'm going to say IP NAT inside, and now it's going to come up and say, okay, well, what's the source? I'm going to say, well, the source is actually, now, you remember, a moment ago when we did NAT overload, I said there's an access list. I created an access list that defines the inside addresses. Not so much anymore. I'm now going to say this one's a static. It's going to be a static local to global mapping. All right, let's do it. So the source is going to be static, and I'm going to say the inside local IP address. Do you see now why I said that terminology is such a big deal? Inside local, it's mine and it's private, so that's my internal address. Inside local address is 10.16.0.200, right? Right? Yeah, that's the web server, 10.16.0.200. Okay, good. And I'm going to go to, now, there we go. What is the inside global? Again, it's my control and it's public. So I'm going to say 203.0.113.3, which again was the IP address right there on that internet connection outside, right? So hit the enter key. I've now tacked up a mapping. Let's do a show IP NAT translations. And I can see somewhere in here. Actually, let me show you a cool command. Clear IP NAT translation, and I'll hit star. Delete all the dynamic translations. Sometimes you use this command when there's something that's stuck in NAT, like you had a bad translation, you changed an IP address, something. You just want to kind of wipe the table. It doesn't cause an outage because NAT rebuilds itself extraordinarily fast. Like the next packet comes in, it's like, oh, I need to build a translation. So I cleared it out. Now I'm going to do a show IP NAT translations. And notice it's already built one, but look at this, such goodness in what I just showed you. Hang on, I'm going to hit the up arrow. Okay, it's building more, right? But look at what happened. I've got this guy, my web server, right? Now up here, it was going out on that one because we were using the NAT overload, which sent it out the interface IP address, the .2. Remember? That was the address that was assigned to the headquarters router. It's the address that we specified in the NAT overload config, but no. We just tacked up, hang on, scroll up right here. We just tacked up a brand new translation. We said for that computer right here, I want it to go out on that IP address. And what just happened? Sure enough, it is. Now, I want to make sure we're really clear on one thing. If I put my computer back over here, right, and I plug this guy back in right here, I'm not going to because we're going to use this guy on the outside. But if I plugged it in here and it went and accessed the internet, what IP address do you think it would use? Do you think it would go out on .2 or .3? .2, right? Why? Because .3 is tacked up just for that web server. For the .200, for this guy that's screaming, it works. That's the only guy that's set up statically to use the .3 IP address. Everything else still uses the dynamic NAT. Hang on, if I go show run, everything else is still going to use this command. This command, which says everything else, the NAT sources go out the pool of public address. I just want to make sure you guys connect those dots, right? Now look at this right here. Hang on. I'll hit the show IP NAT translations again because it's probably built a number of them by now. Yeah, see? My computers just do things. They just go out on the internet, right? Look at this guy right here. How do you recognize a static translation? Like that. It's like no protocol. That means all protocols for this public IP are going to that private IP, right? And then, nothing. It's static. I've tacked it up there, right? So now I'm going to go to my computer. I'm just thinking right now out loud. Bring this up. Hit the enter key. Let's do a refresh. Oh, and I didn't doubt that it worked. Really? Whoops. But it works. I'm actually going. Hang on. Look at this. I'm going to come back here. Let's do a show IP NAT translations again. Let's see, because I know what I'm looking for right here. It's this guy, right? So look at this. Okay. Truth be told, yes, this guy is quote unquote out on the internet. Hang on, let me get my chicken scratch up on the screen again. This computer is quote unquote out on the internet, but the internet is emulated. Like I'm actually on my home network on here, 192.168.1. So it's kind of emulated. So I'm coming in from the 192 network and hitting this, and I can see that. When I look at this translation, it's saying, okay, the outside local, do you get the feel here? The outside local, outside global, that's me on the outside world. My source port on the outside world is this, and the direction is changed. It's now my computer in the outside world that's coming in from 192.168.2.50, hitting the inside global address, this guy right here, on port number 80. That's my HTTP. It then translates right here to the inside IP address of the web server on port 80. That's my it works Apache web server, and communicates back to my computer. I refreshed it twice, so there's two NAT translations that are actually taking place. Oh, that's so cool. Now hang on, we're not done. Because the method of static NAT translation that I just used right here actually consumed that whole public IP. It said that whole thing is dedicated to this computer. So, I mean, what if I wanted to do something crazy? Like I wanted to, it's not crazy, because maybe I have another server right here that's running email, and I say, I want to use port 25. TCP port 25 for my email server. Well, that has nothing to do with TCP port 80, but I don't want to burn my public IP addresses, like give a whole one to this guy and a whole one to this guy when they use completely different port numbers. So that's where we can actually use static PAT. We can use a more specific way of doing this. Watch what I'm going to do here. I get so excited. I stutter. So right here, I'm going to highlight this line. I'm going to say no. Bam, I'm going to remove that static. It's like, hey, this is in use. People are accessing it. Oh, sorry, took down the website. So I'm going to hit the up. Actually, let's do, hit the up arrow. I'll delete the no. Actually, I'll go right back here. So I'm going to say inside source static. So if I want to get more specific, right, instead of just going in like I did right here and saying, okay, here's the inside local address, I can say, I want to just use a specific port number. So I'm going to use TCP to the inside local address 10.16.0.200, right? And it's saying, what is the local TCP UDP port number? And I'm going to say for port 80. And I'm going to say, we'll go to the global address right here. Oh, hang on. Hit the question mark. And the global port number will be port 80, right? Now, that's going to do two things. One, only port 80 is going to be allowed to forward in. So if somebody hits port 25, 443, anything, not going to forward in anymore. Port 80, that will pass straight through. But also remember, flip it. The only thing going out will be port 80. So if everything else running on that Apple computer right there, like stock quote trackers, email, everything else, it's going to be going out that's not using port 80, and it's going to use the global overload translation, right? It's going to use that one because only port 80 matches that static NAT mapping now. Does that make sense? Now the cool thing about this is we could then go in and say, well, let's just say that I don't have an email server, but let's just say that email server right there had the IP address. Oops, get back to my slide. Had the IP address 10.16.0.201, for example. What I could do then is hit the up arrow and start splitting off that public IP address for multiple uses. Now I can't use port 80 again. Let's just say port 25. That's our SMTP. That's our email, right? Now I can start tacking up all kinds of static NAT translations. And I'll say include IP NAT in my show run. And look at this. Oh, that's so cool. It comes up and says, hey, I'm going to allow these port numbers through to each one of the devices. I'm using my public IP addresses to the maximum. One public IP actually reaching two different servers. And I could expand that until I reach the point where I have two servers using the same port numbers. Two web hosts on port 80, for example. Then I've got to use a different public IP because obviously there's only one port 80 that I can use. That is how you do it. That's how you configure static NAT mappings for a hosting environment. And I want you to catch the gravity of what I'm walking around. I'm just talking to myself. The gravity of what you just learned just now. You can now set up a network, right, to allow public internet access using NAT overload. Bam, internet access is up. You can now set up that same network to host servers. You can set up a hosting environment where, and this is where I'm like, do you know what power you have? With great power comes great responsibility. Spider-Man. So at your house, you can go in and set up remote desktop servers. You can set, something I just did. I have a rental home, right? And I have a camera that's running at that rental home I don't watch my renters, but just to watch the house from the outside perspective, so that I can see when I can make sure the house is not burning down or something like that without actually going there. And I'm like, and obviously I've signed, and they signed, and we all know that that's there. So I set up a static NAT mapping to that camera running at their house, so I can access it remotely, and I'm able to see that. All that's, so don't just think I'm hosting a web server. I'm hosting anything, and you now have the power to make it happen. I hope this has been informative for you, and I'd like to thank you for viewing.